Okay, Dwayne, we're going to take a look at the stair project we're going to be building this week. You can see here we've got a simple flight coming up to a landing, balusters, spindles, rail. We're going to be doing a mitered stringer on the outside, plain stringer up against the wall, and have to build our treads. And it's a fairly elaborate finishing project. So I'd like to take some time here to go through and give you some tips moving forward. If we take a look here to the second page, we can see the orthographic projections. We got the requirements up top here. And a couple things to note here is the precision that's going to be required. We are going to be dealing with a couple millimeters of tolerance on this project to reflect the finished nature of it. Okay. We take a look here, this is our framing, okay? And so this is where we're going to need to start. This is likely where we're going to start to develop some compounding errors. You can see that we've got a total rise to the top of the framing of 345. Of course, we have to consider the fact that there would be a finished landing on top of that. So when we're breaking out our rise and our run, we have to remember that that would be from finished floor to finished floor, okay? It's going to be important at this step here that as you start to fit things that you're double checking some of these measurements and you're thinking about what's going to happen when I add finishes. If we start off out of square, out of plumb, out of level on this, it's only going to telegraph through to later on in the project. And of course, thinking about the fact that once we put finished treads on here, we have to have the same unit rise running all the way along. So I would say once you've cut your framing here, lay it out, maybe pin it together lightly before you commit to any thorough fastening, and make sure to double check these numbers, make sure to pull parallel off this back wall, and make sure that everything is nice and square and where it should be, okay? These two legs here to support the landing, those can just remain as 2x4. We're not going to trim those out. Those would reflect the framing that isn't there that would be on the job site. Now, the finished stair is going to be supported by these cut stringers. Then up against the wall right here, we will be putting a plain stringer, and that's going to give us a semi-housed stringer, which we've talked about already. On the outside, we are going to fit a mitered stringer, and I'll get to that in a moment. One thing to note here is the requirement to put a spacer block in right here. Okay, the idea is I would pre-install my framing, then I could slip in my plain stringer after the fact, okay? Here's our newel posts, okay? Now, you can see that the notches have been laid out. We'll get into more in-depth calculation of these notches later on, but in reality, you don't calculate these, okay? So once your stair is framed, you would actually take your newel posts, hold them in position, and transfer these marks directly to it. One thing that you're going to need to sort out is, are these notches going to take us to the top of our finishes, or are these notches going to land on framing, then our finishes will butt into them? I want you to think about what the relationship would be given those two options there, and which one might present itself as the easier, more straightforward option, okay? We will need to we need to keep the tops of these newel posts at their factory edge there. So we're not going to install our newel posts and then measure up and cut them to height. That's not how stair builders build stairs. Typically, we're using pre-made newel posts. They might have a finial or a ball at the top there, or even just a bull nose, and we can't cut those off in place and refinish them on site. So we need to think about keeping the tops of our newel posts factory and pulling down, okay? I've given you the overall dimensions of these newel posts, and you'll want to machine those and joint them down and all that kind of stuff. Do some pre-sanding on them, break the edges before you install them, and make sure to double check with me before you commit to installing any of these so that we can have some chance to have a little bit of a discussion, making sure the fit up is okay with that. You can see this newel post here is half the thickness, and that is to reflect that this one would be planted up against the wall. That's called a half newel, okay? All right, here's our stringer details for our finished stringers. This is a typo here. That should say plain stringer, not planted stringer, okay? The planted stringer would be the cut stringer that gets attached to it to create a semi-housed stringer. You can see here that I've given you some dimensions. That should say millimeters. I think it was edited out. Uh, Over here, this angle has not been defined. I want you to think back, check on your notes for when we did some practical layout of this. The idea here is that the height of this is 40, not this, and that is to tie into your baseboard at the top. And down at the bottom, we need to do a plumb cut to tie into our baseboard at the floor. Again, this needs to be slipped in behind your framing. So it's a good idea that when you create that spacer block to space your cut stringer out, if I go back here, right here, that you potentially cut this a whisker bigger than the plain stringer so that you've got some space to slide it in. Okay. Now, here's our mitered stringer. The first thing you'll notice here is that the nosing line doesn't touch the nosing down here, okay? And I want you to think about that when you take a look at the as-built drawing at the end here, and there has a detail to do with the newel post here, okay? We need to think about which one of these cuts need to have a bevel put on it so that we can attach the riser board. Then we can see in plan view, that'll answer your question there. So I'll let you unpack this right there. You can ask me if you have any questions about it. Now, how do we transfer our cut lines from our framing to our mitered stringer? That is with a preacher block, okay? And so I demonstrated this already. I went over it. This would be the basic requirements of your preacher block. Remember that this is just scrap material. The only thing required of this preacher block is that it is equal to the thickness of your riser board, okay? Now, I've provided you over the next couple pages here with kind of a step by step. Now, you can see there's no dimensions here. This is strictly a visual clue. This is also kind of your process. So how are you going to build this thing from step one all the way to the end? So you can see we're going to start with our framing. Here you can see our spacer blocks. Of course, these are not exposed, and so you don't need to fuss with doing plumb cuts and C cuts or any type of particular length. Just make sure that they are deep enough down here where our material can slide in and we won't have any exposed kind of holes running through to the wall. And that these are at least equal to, preferably a little bit wider than our finished material here. You can see that the next step is to put our newel posts in. So that might answer a question I posed earlier about the order of operations here, okay? After we put our newel posts in, we're going to install our landing. We're going to pre-build our treads. I've done a demo on that already. Remember that the only thing that likely won't be installed on these treads would be these little tiny returns right there, okay? These little returns, if you pre-install them, there's likely could be a gap between here and the return. And so through my experience, and not just my own, but other stair builders, these are best left off till the end. You finish the stairs, you cut yourself a bunch of returns, some a little bit longer, some a little bit shorter, and then you just fit them in place with a little bit of glue and a micro pin, okay? You can see, oh, let me zoom in here. You can see that we have to put a nosing over the end grain of our 1x material tread. So how are you going to make this cut? How are you going to make that nice 45 there? How are you going to make this cut here? I've seen some students use a bandsaw. I've seen people use a miter saw. I've seen people use a table saw. My experience as a stair builder, I rarely had a bandsaw on site, and so I was limited to using things like a table saw or a miter saw. But I just want you to think about the requirements to have a nice joint here, no gaps, no waviness, and that I would suggest that you pre-install this nosing onto the tread before you install the tread. Like I said, just keeping the return till later. You can see at the top that there's no requirement to put the return here because this is going to butt into the newel post. So think about maybe pre-building the tread to its full dimensions, and then how are you going to create this notch in the corner there? And if I zoom out here, we can see at the bottom, we are going to have a corner missing from the front of this tread here. So how are you going to cut that? How are you going to fit it into position? Think about back beveling. We've talked about that already and what the advantages of putting a back bevel on something are, okay? You can see that we are going to install our rails before we put in our spindles here, okay? And so This rail is going to have a plow in the underside. You're going to have to lay out a center line coming off this newel post along these treads here. And you're going to have to think about the spindle spacing for the stairs themselves and the spindle spacing for the landing. Here you can see the detail of how our mitered stringer, which is actually a bevel, is going to receive our beveled riser board, okay? When you glue these up, you glue them up in position, okay? Be aware of extra glue squeeze out so that you're not having to sand it back afterwards, okay? So make sure you do a nice clean job, use plenty of glue, clean it up with some water and a rag, then make sure to do a nice detail sand at the end to create a slight round over, a slight bevel on these corners. No sharp corners anywhere on this project. We want to prevent customers from getting slivers, as well as I want to remind you that paint does not like to stick to sharp corners. It doesn't take much to wear that away. Here you can see the spindles installed. Now here we can see the spindles coming down the staircase, and here we can see the spindles on the landing. Now, we had gone over in class two ways to calculate spindle spacing. Up at the top here is going to be our traditional spindle spacing, where our spindles are all installed on a level surface, parallel, of course, always to our newel posts. Down here, you can see that our spindles come down and they land on the treads. So this would be the second way that we do spindles, which is a little bit more straightforward. The important thing is that these spindles here, and here, you can see that the edge of the front edge of the spindle here lines right up with the riser below. So you'd want to think about where would this spindle go? Where would this spindle go? And then you can see that we want to space one more spindle equal distance between those two, okay? We are going to be installing fillets, which is shown here, the little fillers, in the plow of the rail. That's going to secure the spindles at the top, okay? And at the bottom, we are going to mark a center hole and we're going to drill and dowel these spindles in place here. Now, when you do the spindles running down the stairs here, it's very common that you're not going to have the same spacing here and here as you do in between. That's a tough detail to get if you want that on the job site. And thinking about that, if a client ever wanted all equal spacing from start to finish, you'd want to think about installing your newel posts in line with the nosing or the riser first. Up at the top here, there would be no reason for us to have a different space anywhere along here, okay? If you notice our fillets here, by design, they are not cut equal to the depth of the plow. It's always nice to put a little lip on things. We call that a reveal in the finishing world, and that just gives it a little bit more lines, shadow lines, a little bit more to pop. And I want to remind everybody that trying to make things perfectly flush is quite difficult. Likely you're going to have some that would be a little bit proud and a little bit short, meaning they would be up inside the plow there. So it's typically best to give them a little reveal, an eighth of an inch, something like that is good. If you look right here, this is an ideal spot for us to secure our rail. So what are you going to do at the top? At the bottom here, we can hide a screw in the plow of the rail. What are you going to do at the top? What are you going to do up here? I want you to think about the what we talked about with securing in the classroom there. So what are our options for concealed fasteners? If we can't conceal the fastener, how are we going to think about drilling a clean hole and plugging it? And what should the grain orientation be on that plug? And what material should I cut that plug out of? So on and so forth. Okay. So that concludes this stair project. I would like you to touch base with me several times over this project. Remember that it all starts up here with the framing, okay? And so if we don't nail the framing early on, we really are going to have problems making our finishes work, okay? Take your time on this project. This is about the details matter, the finish matters, no pencil marks, no machine marks, no sharp edges. Good luck.